Earth channel. The James Webb Space Telescope has detected water vapor around a rocky exoplanet that orbits a star located 26 light-years away from Earth. Now, astronomers are trying to determine whether that water vapor is an indicator of what would be the first known presence of an atmosphere around a rocky exoplanet. Small, cool red dwarf stars are the most common stars in the universe. The exoplanets found in the habitable zone, the perfect distance from a star to allow the planet to be warm enough to host liquid water on its surface, often orbit red dwarfs very closely since they aren't as warm as the Sun. Although the scorching temperatures make the planet too hot to be habitable, observations of GJ486b with Webb's near-infrared spectrograph revealed hints of water vapor. A study detailing the findings has been accepted for publication in the Astrophysical Journal Letters. The presence of water vapor could suggest that GJ486b somehow has an atmosphere, despite its heat and proximity to the star. Water vapor mystery on GJ486b planet. While water vapor has previously been detected on gaseous exoplanets, scientists have yet to find an atmosphere around a rocky exoplanet. Doing so would be a landmark event since that would make it similar in a way to planets in our solar system like Earth and Mars, which are considered rocky. In a statement, Kevin Stevenson, who is the principal investigator on the Webb Observing Program at the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, and a co-author of the study, emphasized the significance of discovering water vapor in an atmosphere of a hot rocky planet, as it would be a significant breakthrough for exoplanet science. However, he also cautioned that they need to be cautious and ensure that the star is not responsible for the observed water vapor. The team observing GJ486b watched as the planet crossed in front of its star twice, and then they used multiple methods to analyze the data captured by the telescope's instruments. Sarah Moran, who is a postdoctoral research associate at the University of Arizona in Tucson and lead study author, that they had observed a signal which is most likely caused by water. However, it is still uncertain whether the water is a part of the planet's atmosphere indicating the presence of an atmosphere, or if it is just a water signature originating from the star. Water vapor even exists on our Sun in sunspot regions. Sunspots or star spots are areas that appear dark on stars because they're cooler than other parts of the surface. Since the red dwarf star hosting GJ486b is much smaller and cooler than the Sun, it may contain even more water vapor in its star spots, enough to create a signal that could be misinterpreted as a planetary atmosphere surrounding the closely orbiting exoplanet, according to the researchers. Ryan McDonald, a NASA Sagan Fellow at the University of Michigan in Ann Arbor and a co-author of the study, explained that they hadn't detected any signs of the planet crossing any star spots during the transits. However, this doesn't imply that there are no spots on other areas of the star. He further added that this is precisely the physical situation that could create the water signal in the data, and might appear like a planetary atmosphere. The heat and radiation from the star would likely erode GJ486b's potential atmosphere over time. If the exoplanet currently has an atmosphere, it would need replenishment from a constant source, like steam from volcanoes. Future observations of the planet using different instruments on the Webb telescope could reveal additional details about the source of the water vapor.